Okay, this is a quick little video to show you how to work with roots, square roots, rational roots. So I'm going to put an ink color. Let's get a nice bright color for us to work with. And let's just say we have a square root of something like this. Square root of 4. What does that mean? It means some number times itself equals 4. So what you can do underneath the square root is you can factor it until you get the same number times itself. In this case, it's 2 times 2, which means the square root of 4 is equal to 2. Okay? We can also rewrite that square root of 4 as the square root of 2 times the square root of 2. Now, when we do a problem like this, the square root of 2, which means this number times itself equals 2 times 2 equals 2. But the question comes, what is a rational and what is an irrational root? Well, a rational root is something like the square root of 4 that comes out with an even number. Now, if you have something that has like the square root of 2, it comes out with a fraction. If you did it on your calculator, you'd get like something like 1.732, and it goes on. That's an irrational root because it's not an even number. It doesn't end up terminating. It ends up going on forever. Other types of irrational numbers are numbers like pi, and we estimate it by saying 3.14159, so on. And other numbers that are irrational are like the square root of 2, square root of 3, square root of 5 are some other examples of irrationals. So one thing that you're doing in the lesson with roots is you're taking a number like the square root of 27. Well, all you have to do, this is kind of simple, this is going to be written as the combination of a rational root, square root of 9, times the square root of 3. And you see how 27, the factors of 27 are 9 and 3. Well, we know what the square root of 9 is. It's just 3 because 3 times 3 is 9. And the square root of 3 is left over. So we could say that the square root of 27 equals 3 times the square root of 3. That's simplifying a root. Let's do one more. Let's take the square root of, let's just take any number. I'll just say 108. Square root of 108. Well, how can I write 108 differently? I could write it as the square root of 2. And this is kind of like a factor tree, isn't it? Times 54, because 2 times 54. And 54 can be written as square root of 2 times 27, can't we? Well, this is interesting. Now what do I end up with? Square root of 2 times the square root of 2 times the square root of 27. Well, we already found out that the square root of 27 from up here on this previous problem is just 3 square roots of 3. And we also found that the square root of 2 times the square root of 2 is just 2. So I'm going to write this as the square root as just 2, and I'm going to times 3 square roots of 3. Well, going back over here then, 2 times 3 is just 6 square roots of 3. So connecting these, we could say that 6 square roots of 3 is equal to 108. I hope